Hello, I am Bill Liegman, Field Technical Service Manager for Whitmore, a company that manufactures and provides reliability-proven products to help equipment operate efficiently and protect their components. Today, we will see some applications of this product as we go look at an automatic lubrication system and show you how to inspect that system. Behind me is a Page dragline that uncovers overburden and reveals coal underneath. This machine has a 320-foot boom and operates and lifts a 62 cubic yard bucket. When they fill that bucket with dirt, it would be like digging a pool 25 feet long, 15 feet wide, and 5 foot deep in one swoop. With the extreme weights involved in this operation, the equipment obviously has large bearings, large shafts, large bushings, and requires a very extreme pressure lubricant. One of the lubricants used on this machine is the Caliber 3M product. It is a lithium-based product fortified with 3% moly. It has a 620 weld point and also has a 500 degree Fahrenheit dropping point. These type extreme pressure additives are needed to protect this equipment during its operation of the heavy lifting involved. This product is used on 16 draglines and shovels throughout the Texas, Louisiana, and Mississippi area. It is also used on many pieces of equipment worldwide. The other product involved here is the Gearmate 1000 ICT Heavy. It is an open gear product that is used on the open gearing for the hoist and drag, the swing rack, and the Propel gearing. It has a 1000 weld point and is heavily fortified to protect this machine that when it's lifting a bucket of dirt can be lifting and moving up to 180 tons of weight. This product, as mentioned previously, along with the Caliber, is also used on many draglines and shovels worldwide. The other product being used here is the GF365 synthetic gear oil lubricant. It is an extreme pressure synthetic oil that has anti-wear additives and anti-foam additives in it. It protects all the enclosed gear cases and the large gearing involved in turning this machine and lifting the bucket up and down. There are some machines that have used this GF365 gear oil and continue to use the same oil in a gear case for up to 10 years. So it is a very robust product also. As we move closer to the machine, we'll get a look at some of the applications of these products in service. As you do an inspection on a lubrication system or on the machine applications, one of the important things to know is what products are being used and where they are going. Many machines will use multiple products. This machine uses 3 products. Some machines use up to 5 different products. This machine is employing the OilSafe labeling system, which identifies each product and also identifies what system those products are being used on. Here, this machine has labels on the bulk fill lines above me. They identify which lines to hook up for the distributor of the lubricants to make sure that they fill the right lubricant in the onboard tanks. As you begin your lubrication process, after you lock out and tag out, you then go through a visual inspection and start looking at the lubrication points, which we'll discuss here in a minute. As you begin inspecting the lube systems, one of the interesting aspects of a dragline is it technically has a left and a right side. Components on the left are identical to the components on the right. As you do your visual inspection, you can therefore look at each side and determine if they're the same, if one looks under lubricated or one looks over lubricated. As you do your visual inspection, you're trying to look for a fresh seal of lubricant around those points that receive lubricant. On this Propel machine, the walking mechanism, you can see the large shafts that have bearings and bushings. You're looking for a fresh deposit of lubricant on that. The injector bank that services them has a purple tag identified with it, which indicates it's using the caliber product. It also indicates what system that is on. So if you encountered a problem out here, you could go upstairs to the actual lube system and determine which lube system that applies to and begin your troubleshooting process. As you inspect the machine for proper lubricant on the grease applications, one of the things you're looking for is a fresh seal of lubricant, because part of the lubricant's function is to keep contaminants out. This is obviously a dusty and dirty environment, and any grit that gets into those bearings and pins can cause excessive wear. This is the fairlead assembly on the machine that has a series of horizontal shivs and vertical shivs and support rollers. They're all receiving a fresh deposit of lubricant, indicating that the grease is doing part of its job, which is keeping the contaminants out. Whenever you do any kind of service work on a machine, especially at a customer site, it is important to keep safety as the #1 factor in mind. When approaching a machine, the first thing you want to do is communicate with the operator so they know you're coming aboard. And on days that you're doing inspections, it's important to lock out and tag out. Each machine will have its own procedure. This particular machine has a lock box where people apply their locks and take their key with them. That way the machine will not operate and no one can move it until all the locks are operated. So we're going to be doing an inspection here, so we would lock out and tag out. And remove our key. Now, MSHA requires that this lock cannot be removed by anyone else but myself. So it's important to remember when you finish your work and leave the machine to take your lock so that they can go back into operation. One of the other important things to note, if you are on a machine and have to look at things when it's running, because of the loud operation of this machine, especially in the back, double hearing protection is required. You'll need internal earplugs, which you insert into your ear canal, and then you'll also need a set of earmuffs to go over your ears for double hearing protection. On a dragline like this, the automatic lubrication system is called a Centromatic lube system. Many machines throughout the world use this type system. It's also referred to as a single line parallel system. There are 5 major components of that type of a lube system. There's the timing unit or control unit, which programs the sequences and cycles when the lubrications activate and dispense lubricant. There's also the vessel that contains the lubricant. Here's an example of the bulk tanks that are used on this machine. These are identified also with specific labels, color-coded, that identify which product is being used. It also identifies where it's being used throughout the machine. In addition to that, it also has these IR codes that if they are scanned, it will give you the SDS information for the products that are used on this machine. The other factors that are involved would be the pumping units that deliver the lubricant. These are air-operated pumps. They build extreme pressures. So one of the things to be very conscious of and aware of when working on a lube system is to always make sure that there's pressure relieved in all the systems you're going to be working on. They all have gauges that indicate what pressures are being operated on and where they're at. If you ever see pressure on a gauge and are going to disconnect the line, make sure you relieve that pressure, because there can be upwards to 3,500 pounds of pressure behind that fitting or behind that hose. The other item involved in the lubrication system is the supply line. It's referred to as the main supply line, which pumps lubricant out from here all the way down the machine throughout the machine into that particular system. It's a single line that traverses through the machine for that particular system. In the case of the boom point, this line will travel upwards to 400 feet, pumping lubricant to operate all of the injectors that are in that system. The other thing that's involved is the fluid controls. These are all of the items located here. Directional valves that transfer the lubricant to the dig or propel side. Draglines and shovels have two motions. One is called dig excitation, the other is called propel excitation. In the dig cycle, the machine is loading dirt, lifting dirt, and swinging and dumping the dirt. That's called dig. In the propel side, the machine is simply walking, so it's not moving any other equipment. So in order to make sure you're not lubricating things that don't need to be lubricated at that time, both systems operate only when they're in that particular cycle. On the lube panels, when you're testing them, they will have both a dig and propel cycle switch, so you can switch it to either cycle to see which system you want to test and activate. One of the other notes on this particular machine, they're employing Air Sentry Guardian breathers on the top of the tanks to keep the lubricant clean. These breathers are gold when they're first put on, the desiccant is. As they absorb moisture, they will obviously then turn to the dark green color. The Guardian breathers have the unique design of having a check in them, which as the tank breathes, that air goes directly into the atmosphere. Therefore, the desiccant in the breather lasts 3 to 4 times longer than any other on the market. We expect these breathers to last 6 to 9 months before they'll be needing to be changed out. This machine, as mentioned earlier, has 432 SL1 Lincoln injectors. They're called dispensing devices, and a variety of companies make them, but they all look similar and have similar outputs. The SL1 distributes 0.08 cubic inches of lubricant per lubricant cycle. The SL11 injector is a bigger injector that will dispense 0.5 cubic inches of lubricant per cycle. There's also the SLV injector, which is their new design, and it will dispense 0.08 cubic inches of lubricant per cycle. The SLVX is another injector that will dispense 0.32 cubic inches per cycle. And the injector at the top, the SL32, is a small injector that will dispense 0.008 cubic inches maximum per cycle. These are typically used on boom foot pins or boom support cable pins that only require lubricant every so often, but they wish to put them on an automatic system. When you come to test a lube system, each lube panel should have manual lube buttons that allow you to initiate a lube cycle. The general operation of a Centromatic system is that a button is pushed on this particular system, an air solenoid will open. It will send air to the pump, which will pull lubricant from the tank. It will then begin pumping it out the supply line, down through the injectors, until it reaches a certain pressure. At that time, there's a pressure switch at the end of the line that once it is satisfied, it will tell the control panel that it's reached pressure, and it will shut the system off. Contrary to popular belief, when this pump is actually delivering lubricant, it is not dispensing any lubricant out of those injectors. It is a sealed system, and what that sealed system is doing is pressuring that lubricant line. It then moves the pins inside the injectors, which drop a piston, and what's in that chamber then is dispensed into the bearing point. It's important to keep in mind that when you change an injector out and put a new one on, because they're typically tested in oil, that first cycle you will not get grease out of it because there's nothing in that chamber cavity. It has to fill itself after the system shuts off. So once that system reaches pressure, it shuts off. It then takes air off of the pump. There's a vent valve which then releases, and it allows that pressurized lubricant to flow back into the tank. During that process, the injectors reload and put lubricant back into that dispensing cavity within the injector. As you test the system, when you hit the manual button, you'll want to watch the pressure gauges, because this will indicate lubricant pressure going down the line to the system. Because this system is pressure-based, if this gauge doesn't build pressure, if it stops and doesn't go all the way up or shut off, there's an indication that there's something wrong. There could be a couple of things wrong. If the pump isn't activated, you may not have air going to the system. Somebody may have shut the air valve off. The air compressor may not be on. There may be a broken line in that supply line, so any lubricant being pumped is just exiting out of that broken line, so there won't be any pressure reached. The vent valve may be malfunctioning, which means it didn't close, so the lubricant you're pumping will go through the vent valve and back into the tank. So whenever this pump is operating, there should be no lubricant going back into the tank. The only time the lubricant comes back to the tank is when the pressure switch is satisfied, it shuts the system off, the vent then opens up and lubricant flows back into the tank. This gauge, depending on the system, will steadily climb and build up to the appropriate pressure that that system set up. Some of these are set up at 2,200 pounds. Some of them are set up at 3,200 pounds. The one that goes to the boom point will be set a lot higher because it has to develop pumping pressure up the 400-foot line. From here to the boom point, you will lose close to 600 pounds of pressure. So while you're showing 2,000 pounds down here, you may only be showing 1,400 pounds at the top of the boom point. It takes close to 2,000 pounds or 2,200 pounds to operate the injectors fully. So you want to make sure there's enough pressure developed to drop those pins and fire those injectors. We'll turn this system on, and one of the other things you look for when the system operates is, as you become familiar with it, some systems are shorter than others. They only have to pump 80 feet, the boom point 400 feet, so there won't take as much time to pump. They will pump up, build pressure, you'll hear it shut off, and then the lubricant will exit. So you can see this gauge going up here directing lubricant to the hoist and drag open gearing. So there was a steady increase in pressure, and now it's venting, so it'll come back down to zero. And this is where it's important to remember, if you're going to work on this system, to make sure these gauges are down at zero or very close to it before you break anything loose. There are a couple of shortcuts you can do when testing injectors. The way they operate is when they pressurize and cycle, the pins that are located on the devices travel downwards. One of the ways to test that is to close the vent valve or the vent line going back to the tank. That system will pressure up, the pressure switch will activate, it'll shut the system off, but because you've closed the vent from going back into the tank, all that lubricant and its pressure will be trapped in the line. So that means that the injector pins should be down for those injectors that are on that system. You can also do that by lowering the air pressure so the pump does not reach the extended pressure that it is to shut it off. If the system shuts off at 3,000, you turn the air pressure down so that the pump basically stalls out at 2,600. You can then go look at those injectors and do the same thing. So we'll fire this system, and then we'll go take a look at those injector pins and see that they fired properly. Is system 1 and 2. There's also, so we stalled the system out and did not let it vent. So now we can go through the machine. we had fired system 1, so throughout the machine, all the injectors will have a tag identifying them as system 1. This is the open gear product. On system 1, it services the hoist and drag gearing, the swing rack and rollers, which are down below. So you can walk through the machine, look at all of these injectors, and see that the pins are traveling down. These particular injectors that show a pin, they're actually shut off, so you will not see that pin travel downwards. Once you do that, you can then go back and relieve pressure, the vent pressure. If for some reason these pins don't go down, you then begin to look for problems. One of these feed lines could be pinched, not allowing the lubricant out. The injector itself could be bad. If it's going to a bearing, the bearing could be froze up, things like that. As long as all the pins go down, you make your rounds, and then you go back and you relieve the vent pressure from the system. When you do that, these pins should then travel back up. So as you can see, they're now coming back up. That means it has dispensed lubricant, and during that venting procedure, when the pins came up, this cavity in here was reloaded with lubricant, and it's ready to go on the next cycle. To again identify tagging, yellow is system 1 and 2. There's also other tags around the machine. This one is purple, indicating grease, so it's easy to identify what you're looking at, what system to go to, and what product it is taking. When you're testing injectors, the other thing that you want to do is occasionally check to find out what they're outputting. These have internal seals in them, and as they age, the seals technically go bad and start leaking. So because the lubricant pressure comes in, if they don't seal off, excess lubricant will go out the feed line to the application point. So what you do is you break the line loose, you then activate the system and watch the dispensing of the lubricant. On this particular system, these are SL1s at about 60%. They put out very little lubricant, and it should only be that amount of your finger that comes out of there. We should see the pin travel down. So this is the typical amount that we expect it to output. If you see excess lubricant coming out 2 to 3 times, we recommend changing this injector. If too many of these injectors are bypassing, it will eventually not allow the system to build pressure, and you'll get a manual alarm that will shut the system off. This is an application of the Gearmate 1000 product on the drag gearing. Up here you'll see the drip tubes that drop lubricant down onto the bull gear, which then transfers to the pinion as this thing operates. One of the things you look for when you're inspecting this system is a uniform black coating onto both the bull gear and the pinion. If there's bare spots or any lack of lubricant, then you need to check the lube system and find out why it isn't receiving the proper lubricant. If the injectors are bypassing or the system setting is set too frequently, the more lubricant you apply, the messier this will get. There's an indication here that there might be too much lubricant going on because it's splattering up into the guard. If an injector is bypassing, when you fire the system, that bypassing injector will drip lubricant out that tube, and it'll probably run down the gearing, and you can see it during your inspection and know that you have to look at something. One of the things this machine has that is really valuable to anybody working on it, there's so many different application points in lubricants. They've got everything identified with what products are being used where. On each gear case, there's a label that identifies which product goes into that gear case. This particular case is a drag case. It's using GF 365 ISO 1000. They also have the pump identified as a gear oil, which again references the enclosed gear, what case it's going to, and the product being used. On this tag, it also has the supplier of the lubricant. This is a Whitmore distributor, ILCO, that delivers lubricant to this mine site. Again, each injector bank in each system has its own tag. We had gear oil there. Now we've got a grease application. It's so much easier to find out what you're working on and what's supposed to go where when they're identified with the OilSafe tag. One of the products that Whitmore makes are desiccant breathers. The Guardian breather is one such item, and it has some unique designs and some unique features to it. First of all, it has desiccant in it, which removes moisture that tries to enter a gear case that can obviously alter the condition of the oil. This machine has 4 hoist cases, 4 drag cases, and 4 swing cases that are using a synthetic oil. The case sizes range from 75 gallons to 175 gallons in the swing cases. It's obviously something they want to keep clean, and part of that is keeping contaminants out and also any moisture out of those cases. The Guardian breather allows them to do that. Its unique design has an isolation check in it so that when this is placed on a gear case, as the gear case operates, it naturally breathes, and moisture that would come in through these top checks and vents would go through the desiccant and get absorbed in the desiccant. Underneath here is a 2-micron particulate filter. There's obviously a lot of dust and dirt in this environment, so that'll keep that out from going into the gear cases. The other unique feature exclusive to this design is this isolation check in the bottom. When that case then breathes the other way and air expels from the case, these checks pop and any expelled air goes out into the atmosphere. It does not go back through the desiccant. This allows the life of this desiccant to remain much longer, probably 4 times more than any other on the market. This machine will have 8 Guardian breathers on all of the hoist and drag cases. They're in the process of installing 8 more breathers on the swing cases, and they also already have these breathers on the lubricant tanks to keep that lubricant clean. We're down below on the tub of the machine, actually inside the machine, but we're looking at the swing rack, the swing pinions, and the roller circle. The injectors that were just viewed up there with the tag drop open gear lubricant, Gearmate 1000, onto the surface of the rollers. That same product is also used on the swing rack and the swing pinions. It's important to remember that introduction of other lubricants can affect the properties of the existing lubricant. As you can see from this machine, there's been some oil dropping down onto the swing rack, and that comes from a leaking swing shaft, which does affect the coating on the swing rack and the swing pinion. This one is holding it still a very good coating still, even though there is some oil trying to wash it off. The other application down here is the center pin. This is what the machine sits on. It's a huge center steel pin with a brass bushing. It's lubricated by Caliber product. And there's a set of injectors down here that have a tag on them that indicate what system it's on and what lubricants it's receiving. One of the other systems employed down here is System 4, which services the house dolly roller pins. It takes a Caliber product because each of these rollers has a pin inside of it, so that as the machine moves and rolls over these rollers, they turn. So it's getting a grease product. The upper part of this machine will move where the tub will basically be fixed, and that's why this system has what's called a tag line. When they want to lubricate it, they shut the machine down or stop it. They then plug this line in to an opening on the injector banks and fire the system. All of those injectors going around the tub, some 130 of them, will then dispense lubricant into those pins. When they're finished, they disconnect the tag line and they can go back to rotating and operating. So as you finish your lubrication inspection, make sure you've turned on all the lube systems, that you've opened all the air valves, and that the systems are working and ready to operate when the machine begins to run. As a final step, communicate with the operator or the machine personnel to tell them that you're finished, and be sure to remove your lockout tag. If you have any questions on how Whitmore can help you with improving your reliability and lubrication practices, please contact us at www.whitmores.com. Thank you.